Hi everyone, welcome to the Introduction to Quadratics test review video. Let's go ahead and get started. On problem 1, they ask us to translate these equations up 2 units and write the new equation. Well, when we do that, when we're translating things up and down, we're interested in our constants. So we're interested in the plus 4 and the minus 4 here. And the way we're going to do that is if we're translating up 2 units, we are going to add 2 to both of those constants. So our new equations become y equals 2x plus 6. And then in B, it's going to become y equals 2x squared plus 5x minus 2. Alrighty, so that's just what we're going to do there. Now let's take a look at translating these equations down 5 units. And the way we're going to do it is we're still going to look at our constant terms, the ones with no variable, and we need to go ahead and subtract 5 units this time since we're moving down 5. So anytime you're moving down, you're going to subtract however many units you're moving down, and whenever you're moving up, you're going to add the number of units you're moving up. So this becomes y equals 3x minus 11, and then part B becomes y equals 1/4 x squared plus 5x minus 9. All right, moving on to number 3. It asks us to make these equations more wide and write the new equation. Well, we know that when a decreases, our function becomes more wide. So a values are the numbers in front of x squared. So if I want my graph to become wider, I would need my a to become smaller. So an equation, you can pick any number less than 3. So I'm going to choose y equals 2x squared plus 6x minus 2. Now when I say smaller, be careful not to go into negative numbers. When you switch the sign on these things, it's going to become complicated. So don't do something like y equals negative 4x squared plus 6x minus 2, because that would be wrong. You want to make sure, even though negative 4 is less than 3, it's still technically, you're looking not at the sign, but the 4 in front. And 4 is bigger than 3, so we want a number less than 3. Okay, so my point being, don't change the sign. Okay, so now part B, we want it to become wider. So I need to make a decrease, so something less than 1/2. But remember, I don't want to change the sign, so I'm going to make it y equals 1/4 x squared plus 5x minus 6, because that makes it wider. 1/4 is smaller than 1/2. Okay, now they're wanting us to make the equations more narrow. Excuse me. So we're going to look at a again, the number in front of x squared. And we want a to increase, so our graph becomes narrow. Now remember, our trick with this stuff is if you, we need to remember a as the amount we exercise. And up here, if the amount we exercise goes down, we're going to get a little bit wider. But if the amount we exercise goes up, we're going to get skinnier or narrower. So looking at part A, we need a number that is larger than y equals negative 2x squared. Now remember, I'm ignoring my sign, so I make sure that my sign stays the same, and I need a number larger than 2. So I'm going to say y equals 3x squared plus 3x plus 7. And that graph will be narrower than the original equation. Now again, I need a to be larger, so I'm going to make this y equals 1x squared plus 2x minus 5. Sorry, a to be larger, so my graph will be narrow. Right. So those two are the answers to number 4. And like I said, you could choose any number as long as it's larger than the a value in the original problem. Now they're wanting us, I'm going to go ahead and scratch number 5 off of the review sheet. So if you're going to attempt to do that, go ahead and ignore it. Omit it. Okay, now they're going to ask us what makes a parabola narrower. Well, we say a parabola is narrow when a increases. When the amount you exercise increases, you're going to become skinnier. So same thing happens with A. If A increases, the graph becomes narrower. And technically, it's the absolute value of A. So make sure that you put that absolute value sign because, for example, if my A value is -2, if I made this -3, even though -2 is larger than -3, technically, it's a larger number, it's still -3 would be a narrower graph because of the absolute value of -3 is 3 and the absolute value of -2 is 2. So just make sure that you aren't messing with the signs and you'll avoid that whole problem. Now what makes a parabola wider? Well, that's when the absolute value of A decreases. Alrighty, let's ignore number 8, omit that, and I will, if need be, I'll clarify that before the test tomorrow, but I really don't think I like those questions, so we're going to omit them. Okay, number 9 asks us to identify the vertex in the line of symmetry for the functions below. Well, remember, vertex is the highest or lowest point on a parabola. Highest or lowest point. Well, in our graph, it's easy to identify this point right here as our lowest point, and that is at 2, -2. Now, axis of symmetry is always going to be the x value of my vertex. So the x value of my vertex here is -2. So I go ahead and write my system of equations, or my line of symmetry as x equals 2. Okay, now on part B, you have to notice that from 34 to 14 we're decreasing, from 14 to 2 we're decreasing. Now from 2 to -2 we're still decreasing, but from -2 to +2 we are increasing. So this is where the switch in the y values happens. That's the change in the pattern. So my vertex is always where the change in pattern happens. So my vertex is at 1, -2. Now my system of line of symmetry, remember, is always the x value of my vertex. So my line of symmetry here is x equals -1. So make a note that the line of symmetry is always the x value of your vertex. All right, moving on to page 2. This is problem 10, and it asks us, it says a cat jumps out of a tree. Its height and time can be measured by the function h of t equals -2t squared plus 2t plus 12. And when the height in feet is h and the time is second is in t, fill out the following sections about the cat. Well, they want us to factor the equation, and they ask us to remember GCF first. Well, a couple things about GCF. One, the number has to go into all of the coefficients in your terms. And the number I recognize that goes into all of these is 2. But because there's a negative out front, I'm going to go ahead and pull out a -2. And when I pull out a -2, that leaves me with a t squared minus t, because remember my sign changes because I'm dividing 2t by -2, and then a -6. So I pulled out my GCF first, and now I have to figure out if I can keep going. Well, I can, because I can factor what's left inside the parentheses. So when I do that, I notice, if you're ignoring the -2 outside, I can set up shop because there's not a number in front of t squared. So I'm going to set up shop. I put a t in the front of each set of parentheses in each one of my factors. And I need two numbers that multiply to -6, always multiply to the last number, and add to the middle term, or my middle coefficient, which is -1 in this case. And the two numbers that come to mind are 3 and 2. And they have to have opposite signs because they multiply to a negative number. and they have to add to -1. So -3 is going to get the negative sign, and 2 is going to get the positive. Well, now my function, or my equation, is completely factored. I didn't even need to use the box method. Now, if you did use the box method, it's fine as long as you factored out your GCF first, okay? So now let's move on to what are the factors. Well, my factors are -2, t minus 3, and t plus 2. Those are the three things that are being multiplied together, or the three parts we broke our equation into. They want us to complete the table and graph for the equation. And in order to do that, I'm going to go ahead and take my equation and enter it into my calculator. So I go to my calculator, go to a graph page, and I type in the function, -2, and our function is -2t squared, but I have to use x because the calculator doesn't know the difference. We have to use x as our input variable. So it's -2x squared plus 2x plus 12. I hit enter, and my graph should pop up. Now I'm going to go ahead and plot the point, or come up with my table, and the way I do that is I hit Control T. And now that you have your table, you can go ahead and fill in your x and y values on your review sheet. So when x is 0, y is 12. When x is 1, y is 12. When x is 2, y is 18. And when x is 3, y is 0. Now remember, our x values are time. So these represent seconds. So at 0 seconds, the cat is 12 feet off the air. At 1 second, the cat is 12 feet off the air. And same thing with 2 seconds, it's 8 feet. And 3 seconds, it's 0 feet. Now, my question is, do I need to list 4 and -12? No, because -12, remember, our y values are our height. And that would mean that the cat jumped off the tree and fell 12 feet into the ground. So really, the only points that I'm interested in are those 4 right there. So let's go ahead and fill in our table. And the y values were 12, 12, 8, and 0. And then remember, our y values are our height, and they're in feet. And our x values are in time, and that's in seconds. So my height is at 0, 12. My first point, at 0 seconds, he's at 12 feet in the air. At 1 second, he's also at 12 feet in the air. At 8 seconds, at 3 seconds, it's 8 feet in the air. And at 2 seconds, it's 8 feet in the air. I apologize. I am really scatterbrained. And then at 3 seconds, it's at 0 feet, so it's back on the ground. Now, because this original equation had a squared term in it right here, we know that it's quadratic. And we should know that quadratic equations graph parabolas. So really, if this is my starting point, I should know it goes up and back down. Now, because our table had 2 points that were right next door to one another, you have to be careful and not be misled. And the way I'm going to go ahead and go back to my calculator, looking at the graph, I can find the vertex of this graph by going to Menu, Analyze Graph, and then Maximum, because I know it opens down so it has a maximum. Then this starts blinking and you get a little dotted line, and what you should do is click to the left and then click to the right of where you know the maximum is, and then it zooms out. Well, here's our vertex. Our vertex is the highest point on the parabola, and it's at 0.5, 12.5. Well, that means our x value of 0.5, that means at 0.5 seconds, the cat was at 12.5 feet in the air. So you kind of have to incorporate that point because it's kind of important, even though it's not listed on our table. Okay? So that's why this point up here makes sense, that it would kind of arch up above that. And if you think about it, when a cat jumps off a branch, it kind of goes up first before it starts falling. So it makes sense. So the maximum value is always the y value of our vertex, but the maximum height the cat reaches is at 12.5 feet. And like I said, you go to Menu, Analyze Graph, Maximum. Okay, now the vertex we already said was at 0.5, 12.5. That's the highest point in our little parabola. And they're asking us how long the cat was in the air. Well, if it started jumping at 0 seconds and it finally hit the ground at 3 seconds, then it was in the air for 3 seconds. The domain are all of my x values of my graph. Well, any point along this line or my parabola that I've created has an x value between 0 and 3. So I write this as 0 must be less than or equal to x. That means 0 has to be less than or equal to x, and x has to be less than or equal to 3. Now my range are all my y values. Well, the lowest y value I had was at 0, and the highest y value I had was at 12.5. So my range is 0 is less than or equal to y, which is less than or equal to 12.5. Alrighty, let's move on to our seagull problem. It says a seagull dives into the ocean to catch a fish, and its height and time can be measured by the function h of t equals 1/2 t squared minus 4t. Again, h is our height and t is our time in seconds. Well, the equation's given to us in the problem. It's h of t equals 1/2 t squared minus 4t. And they want us to complete the table and graph for the equation. Well, remember, I go ahead and go to my calculator. I'm going to start a new graph page. And I type in my equation 1 over 2 x squared. Remember, we have to use x plus or minus 4t, or minus 4x. And then hit enter. And there's your equation. Well, this equation is opening up, which makes sense because the number in front of x squared is positive. So I'm going to go ahead and find, hit Control T. And remember, this time it makes sense that there would be negative height values because he's going below water. So at 0 seconds, he's right above water. And then he starts diving in. At 1 second, he's negative 3.5 feet. That means he's 3.5 feet below water. At 2 seconds, he's 6 feet below the water. At 3 seconds, he's 7.5 feet below, so on and so forth. Well, let's, while we're in our calculator, go ahead and find our vertex. Since this opens up, it's going to have a maximum. Or sorry, not a maximum, a minimum. And so I go to Menu, Analyze Graph, and then Minimum. And then once again, I click to the left of where I think the minimum is going to be and to the right. And it should make sense. The minimum is down at the very tip of our parabola, and it's at 4, negative 8. So the lowest the seagull is going to go is negative 8 feet. So let's go ahead and go back and fill in our answers and fill in our table. When the x value was 0, the height of the pelican was 0. When there was 1 second, the seagull was negative 3.5 feet. At 2 seconds, it was negative 6. At 3, it was negative 7.5. At 4, it was at negative 8. And then at 5 seconds, it starts coming back up to negative 7.5 again. So I plot those points. My y values are my height. My x values are my time. So we're at 0, 0. Then we're at 1, down negative 3.5, or down 3.5. 2, we go down to 6. 3, we go down to 7.5. At 4, we go down to 8. And then at 5, we start coming back up to negative 7.5. And then you can just kind of sketch through those points and judge what the rest of your parabola is going to look like. And actually, I'm going to go ahead and mirror the other images. So I'm going to go ahead and put a dot here, go over one, go up to where the other dot was, and then one more. So I'm going to stop at 0, 8. And there's my nice little parabola. Okay. So what does the x-axis represent? Well, it represents time. The y-axis represents height, of the seagull. The max or min, well, this one has a min, and that is at -8. It reaches its depth at 8 feet, so it's -8 feet is the minimum. The vertex is at 4, -8, so at 4 seconds, it's -8 feet. And then the line of symmetry is always my x value of my vertex, so it's x equals 4. Remember, that line of symmetry is what's going to divide your parabola into 2 evenly. It's a vertical line that divides your parabola into 2. And if you notice, it crosses the x-axis at 4. How long was the seagull underwater? Well, it started at 0 seconds, and then it finally came up at 8 seconds. And the domain for the amount of time the seagull spent underwater, well, domain is time, started at 0 seconds, it's less than or x, and then the largest amount of time, or the highest time value we had was 8 for it being underwater. So it's at 0 is less than or equal to x, which is less than or equal to 8. Now, what was the range for the amount of time spent underwater? Now, that's our y values, and so it starts at 0 and goes down to 8 feet. So our y values are 0 is less than y, which is less than or equal to -8. Oh, I'm sorry, we should start with -8 first because it's lower. -8 is less than or equal to y, which is less than or equal to 0. Now they start asking us questions. If the fish is 10 feet deep, will the seagull catch the fish? Well, the lowest the seagull went was 8 feet. So no, it would never reach 10 feet deep. So the answer is because the seagull only goes 8 feet under. Okay, now the next question says, if the seagull can only hold its breath for 10 seconds, will he be able to catch the fish? Well, yes, because he was able to catch the fish, or the fish in our graph, in 8. He didn't take longer than 8 seconds to catch the fish, so 10 seconds would allow him plenty of time. Okay, now they're asking us to write the parent function for the following equations in number 12. Well, in A, we notice an exponent of 2 being the highest exponent. So we know this is quadratic. And the quadratic parent function is y equals x squared. Now B, it says y equals 3x minus 2. And that's a linear equation because the highest exponent is 1 with our x, but we don't see it. It's just an invisible 1. So the linear parent function is y equals x. Okay, moving on to 13. They want us to identify the domain, range, max, and min of each of the following and the axis of symmetry. Well, the domain in this part A of this graph would be our x values. And if you notice, it's going to keep getting wider and wider. So it's going to encompass all x values. It's going to, each value along this x-axis will have a point eventually on it. So the domain is all real numbers, and we normally write it with an R with 2 sticks. The range, we would draw our tide. So our high tide is at 7, and you notice that there's no low tide. Rivers for range. We draw our rivers for range. There's no low tide, so we can't even draw it. So all of our y values are below 7. So y must be less than or equal to 7. Now our min or max, well, since this opens down, it has a maximum, and our maximum is at 7. Our vertex is the highest point, the ordered pair, and that's at 0, 7. And our line of symmetry is the vertical line that divides the parabola into 2. And it's also always the x value of our vertex, so the line of symmetry is x equals 0. Okay, looking at the second graph, we need to graph it. So it says y equals x squared minus 4. Well, remember, our linear parent function is y equals x squared. So I'm going to do the linear parent function in a teal color. If we plug in a 0 value for x, if x is equal to 0, in our y, and we're going to do it in the y equals x squared. If x is equal to 0, 0 squared is 0, so I don't need to move up. 1 squared is 1. 2 squared is 4. Okay, negative 1 squared is going to be negative 1 times negative 1, which is positive 1. Negative 2 squared is negative 2 times negative 2, which is positive 4. So now I kind of have a nice little sketch of what my parent function is like. Now remember, this minus 4 out here tells me that I'm going to shift my parent function down 4 units. So I'm going to do that back in purple. So I shift it down 4 units. Every point that I just plotted, I'm going to move down 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is now, oh, missed one. 1, 2, 3, 4. This is now the new graph of that equation. Well, now we can answer all of our questions. The domain, again, is going to be all real numbers because my parabola is just going to keep getting wider and wider. And it's going to encompass all x values. My range, I draw my rivers for range at my lowest point, and there is no high point because these arrows are going to continue going higher and higher. So all my y values must be greater than or equal to negative 4. That's where my low tide is. Now my minimum value, my minimum y value is at negative 4. And my vertex, or my lowest point, is at 0, negative 4. In my line of symmetry, the line that divides my parabola in two, the vertical line, also is always the x value of my vertex, so it's x equals 0. And if you notice, that is the line that cuts my parabola to where it crosses the x-axis at x equals 0. All right, now we're factoring. Back to factoring. We love factoring. So remember, factoring, 1, you check for GCF. That's the first thing. 2, you're going to see if you can do difference of perfect squares. Are there two things being subtracted from one another that are perfect squares? 3, you're going to try and set up shop. And then the last thing you're going to do is reverse box method. So, on part A, I noticed that the thing that I can pull out here is a 2, and then since there's a negative out front, I pull that out with it. So I'm going to pull out a negative 2, and I'm left with x squared minus 4x minus 12 equals y. So I pulled out a GCF. That's all I can do there. Now I have to see if I can keep going. Can I factor x squared minus 4x minus 12? Well, let's try it. Since there's not a number in front of x squared, I'm going to set up shop. That means I put an x and an x out in front of my parentheses. Then I need two numbers that multiply to negative 12, but add to positive 4. I'm sorry, this should be, no, add to negative 4. And that's going to be negative 6 and positive 2. So now this is completely factored. There's nothing else I can do. All right, now the next one, I can pull out a negative 3 here. So it's y equals, I'm going to pull out a negative 3 out front. And I'm left with x squared minus 6x, because 18 divided by negative 3 is negative 6. And then negative 15 divided by negative 3 is positive 5. So I can now continue to factor what's inside the parentheses. And I just keep bringing that negative 3 down. I set up shop since there's not a number in front of x squared. And I need two numbers that multiply to positive 5 but add to negative 6. And that's negative 5 and negative 1. And now this equation is completely factored. All right, let's move on to 15. It asks us what the parent function is for the following graph. Well, this is a line, so it is linear. And the linear parent function is y equals x. This is a parabola, so this is quadratic. So this parent function is y equals x squared, because that is the quadratic parent function. Okay, y'all, that's all that I have for y'all today, and I hope that this helped, and I hope to see y'all tomorrow morning for any last-minute questions you have, and I hope y'all get a good night's rest so y'all can do well on your test tomorrow. See ya.